Hello friends, I am Udit Gupta of Applied Mathematics branch, IIT Roorkee. I am presenting my PPT on the topic History of Ancient Mathematics. In ancient times, different religions in different eras had a different mathematical approach. In this PPT, we are going to discuss about how mathematics originated and developed in the main civilizations which had a significant amount of contribution in the development of mathematics, which are Egyptian mathematical history, Mesopotamian mathematical history, Roman mathematical history, Greek mathematical history, and Hindu Arabic mathematical history. In Egyptian mathematics, we will be looking onto these topics: origin of Egyptian mathematics, Rosetta Stone, Egyptian mathematical texts, Egyptian numerical system, addition in Egyptian mathematics, and multiplication and division in Egyptian mathematics. The early Egyptians settled along the fertile Nile Valley and they began to record the patterns of lunar phases and seasons, both for agriculture and religious reasons. The pharaoh's surveyors used measurements based on body parts to measure land and buildings very early in Egyptian history, and a decimal numeric system was developed based on our 10 fingers. So they started using basic number system, or we can say counting. Now moving on to the next slide, that is Rosetta Stone. It has a very extreme archaeological importance. The stone of Rosetta is a basalt slab that was found in 1799 in Egyptian village of Rosette. The stone is a broken part of a bigger stone slab. It has a message carved on it, written in three types of writings called scripts. It was an important clue that helped experts learn to read Egyptian hieroglyphs, a writing that used pictures as signs. Without Rosetta Stone, you know nothing about the ancient Egyptians and their development of mathematics. Mathematical texts are evidences and works of ancient civilizations. They help us to understand about development of mathematics till that time. The most extensive Egyptian mathematical text is written papyrus from the Middle Kingdom about 2000 to 1800 BC. It is an instruction manual for students in arithmetic and geometry. And there is another significant Egyptian mathematical text, that is Moscow papyrus. And also from that time, it consists of what are called world problems or story problems, which were apparently intended as entertainment. And next is Berlin Papyrus, that shows us the ancient Egyptians could solve a second order algebraic equation. It is thought that Egyptians introduced the earliest fully developed base 10 numeration system, at least as early as 2700 BC. Written numbers used hieroglyphic symbols for the powers of 10 up to a million. However, there was a no concept of place value, so larger numbers were rather unwidely. Like for a million, we just had to use a 1 character. But for million minus 1, we have to use 54 characters. Here are the hieroglyphs of the respective values. Well, writing a number in Egyptian numeral system is pretty simple, only if you remember the hieroglyphs correctly. For example, for writing 4622, We write 4 hieroglyphs of 1000, 6 of 100, and 2 of 10, and 2 hieroglyphs of 1. As in this numeral system, there is no concept of place value, so the representation doesn't matter much. Well, moving on to the next slide, we have addition in Egyptian mathematics. In addition, we simply add the numbers and write the result in form of the hieroglyphs of the ancient Egyptian mathematics. To multiply or divide numbers, Egyptian used a very similar method to what we call today binary numbers. That is the concept of adding specific powers of 2, we can obtain any unique number. For example, to divide 23 from 299, we take 23 as shown and multiply by 2 both sides till the number in the left exceeds 299, that is after 184, and then checking by taking which values on left and adding them, we get the number 299, and then taking the respective values on right and adding them, we get the answer, that is 13 in this example. Babylonian mathematics refers to any mathematics of the peoples of Mesopotamia, that is modern Iraq, from the days of the early Sumerians through the Hellenistic period almost to the dawn of Christianity. As in Egypt, Sumerian mathematics initially developed largely as a response to bureaucratic needs when their civilization settled and developed agriculture, possibly as early as 6th millennium BC, for the measurement of the plots of land, taxation of the individuals, etc. In addition, the Sumerians and Babylonians needed to describe quite large numbers as they attempted to chart the course of night sky and develop their sophisticated lunar calendar, similar to the what Egyptian. Now, let's talk about Mesopotamian mathematics. In Mesopotamian mathematical history, we have origin of Mesopotamian mathematics, Babylonian numeral system, and Babylonian clay tablets. Now, moving on to the next slide, we have Babylonian numeral system. The Sumerian and Babylonian mathematics was based on a sexagesimal, that is base 60 numeral system, which could be counted physically using the 12 knuckles on one hand and the 5 fingers on the other hand. Babylonian numbers used a true place system where digits written in the left column represented larger values, much as in the modern decimal system. Although, of course, using base 60, not base 10. Here is a picture of Babylonian numericals. As the Mesopotamian numeral system uses place value system, their system was more advanced and convenient to use than the Egyptians. Now moving on to the next slide, we have clay tablets. Like the mathematical texts, clay tablets are a very good source of evidence of work of ancient civilizations, as the idea of the square numbers and quadratic equations naturally arouse in the context of the measurement of land, and Babylonian mathematical tablets give us the first ever evidence of the solution of the quadratic equations. And there is a very famous and controversial Plimpton 322 clay tablet believed to the date from around 1800 BC suggests that the Babylonians may well have known the secret of right angle triangles, that is, the Pythagoras theorem a square plus b square is equal to c square, many centuries before the Greek Pythagoras. Now, after the Mesopotamian mathematics, we have Roman mathematical history. In Roman mathematical history, we will talk about Roman numerals and how to use Roman numerals. Roman numerals are very well known in today's world and were the dominant number system for trade and administration in most of the Europe for best part of a millennium. It was decimal, that is base 10 system, but not directly positional and did not include a zero. That was its major flaw. So that for arithmetic and mathematical purposes, it was a clumsy and inefficient system. Here's a picture of Roman numerals displaying the letters used in Roman numeral system with their respective values, that is I for 1, V for 5, X for 10, L for 50, C for 100, D for 500 and M for 1000. And here is example displaying how to write 1944 in Roman numerals. So, in next slide, we will discuss how to use Roman numerals. Roman numerals are formed by the use of letters, and unlike Egyptian numerals, they are more concise by the use of subtraction depending on the order of the letters in which they are written. If you use a smaller value letter after a larger one, then it's added, but if you use it before the larger one, it is subtracted. For example, XL is 40 but LX is 60. They are written from left to right. There are some restrictions or rules, like you can use only one small value letter before larger one to subtract, and you cannot use more than 3 letters in a row. Also, only power of 10, that is 1 x c, can be subtracted but not v, l or d. And you can subtract letter with value 10 times smaller. For example, 1x is 10 minus 1, which is 9, but you can not express 99 as 1c, trying to minus 1 from 100. It will be written as xc1x. And also, for example, like you can use only 1x but not iix. Now, after the mathematical history of Rome, we have Greek mathematical history. In this, we will talk about ancient Greek numerals, origin of Greek mathematics, then Greek mathematicians, that are Pythagoras and his theorem, Euclid, Archimedes, Hippocrates, and then Greek geometry. Here is a picture displaying Greek Herodianic numerals with their respective values. These numerals somewhat similar to Egyptians, but with the addition of symbols for 5, 50 and 500. In this system, Also, there is no concept of place value like the Egyptians. For example, there is a flaw in the example given, as for writing 4672, we have to use one symbol of 500 and one of 100 instead of using six symbols of 100. So, it will be written as four symbol of 1000, one of 500, one of 100, one of 50, two of 10, and two symbols of 1. Greek mathematics refers to the mathematical texts written during and ideas stemming from the Archaic period through the Hellenistic periods, extend from the 7th century BC to the 4th century AD. The word mathematics itself derives from the Greek word mathema, meaning subject of instruction. The study of mathematics for its own sake and the use of generalized mathematical theories and proofs is an important difference between the Greek mathematics and those of the preceding civilizations like Egyptians, Romans, etc. Now, we will learn about some of the great Greek mathematicians and their works. These mathematicians have contributed to mathematics very widely and revolutionized the history of mathematics. As we are very familiar of this name, Pythagoras is one of the greatest mathematician in the history of mathematics. The Pythagoras of Samos was an ancient Ionian Greek philosopher and the eponymous founder of Pythagoreanism. Pythagoras is most famous today for his alleged mathematical discoveries. Many mathematical and scientific discoveries were attributed to the Pythagoras. Now, we will learn about the Pythagoras theorem. Pythagoras has commonly been given credit for the discovering the Pythagoras theorem, a theorem in geometry that states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the two other sides. That is, if in a right angle triangle A, B, C are the sides of the triangle and C is the hypotenuse, then A square plus B square is equal to C square. The Pythagoras theorem was known and used by the Babylonians and Indian centuries before Pythagoras. But it is possible that he may have been the first one to introduce it to the Greeks. Some historians of the mathematics have even suggested that he or his students may have constructed the first proof. The next Greek mathematician we will talk about is Euclid. Euclid is one of the most prominent mathematicians of Greco-Roman antiquity, best known for his treatise on geometry. Euclid compiled his elements from a number of works of earlier men. Euclid understood that building a logic and rigorous geometry and mathematics depends on the foundation, a foundation that Euclid began in Book 1 with 23 definitions, such as a point is that where which has no part, and a line is a length without breadth. Five unproved assumptions that Euclid called postulates, now known as axioms, and five further unproved assumptions that he called common notions. Next, we have Archimedes. Archimedes was a great mathematician, physicist, engineer, inventor, and astronomer, considered to be the greatest mathematician of ancient history and one of the greatest of all time. Archimedes anticipated modern calculus and analysis by applying concepts of infinitesimals and method of exhaustion to derive and rigorously prove a range of geometrical theorems, including the area of a circle, the surface area and volume of a sphere, area of an ellipse, and the area under a parabola, the volume of a segment of a paraboloid of revolution, the volume of a segment of a hyperboloid of revolution, and the area of a spiral. The next is Hippocrates. Hippocrates of Chios was one such Greek mathematician who applied himself to these problems during the 5th century BCE. His contribution to the squaring the circle problem is known as the Lune of Hippocrates. His influential book, The Elements, dating around 440 BCE, was the first compilation of the elements of geometry, and his work was an important source of Euclid's later work. For the ancient Greek mathematicians, geometry was the crown jewel of their sciences, reaching a completeness and perfection of the methodology that no other branch of their knowledge had attained. They expanded the range of geometry to many new kinds of figures, curves, surfaces, and solids. They changed its methodology from trial and error to logical deduction. They recognized that geometry studies eternal forms or abstractions, of which physical objects are only approximations. And they developed the idea of the axiomatic method still in use today. So the Greeks had a very huge impact on the development of the field of geometry in mathematical history. Now, after Greek mathematical history, we have Arabic mathematical history. In this, we will talk about origin of Arabic mathematics and the development by Arabics in the field of algebra, cubic equations, induction, and negative numbers. Now let's talk about the Arabic mathematics and about the mathematician Al-Khwarizmi. Algebra is derived from the Arabic word meaning completion or reunion of the broken parts. Muhammad ibn Musa al-Khwarizmi, a scholar in the House of Wisdom in Baghdad, is along with the great mathematician Diophantus known as the father of algebra. In his book, The Compendious Book on Calculation by Completion and Balancing, Al-Khwarizmi deals with the ways to solve for the positive roots of first and second degree linear and quadratic polynomial equations. Now, we will learn about what developments were done by the Arabics in different fields of mathematics. For example, we have algebra. Aljabar meaning completion or restoring is the process of removing negative units, roots and squares from the equation by adding the same quantity to each side. For example, x square equals to 40x minus 4x square. In this, minus 4x square is a negative unit. So, we will add 4x square both sides. So, it will be reduced to 5x square is equals to 40x. Next, al Makwabala meaning balancing. It is the process of bringing quantities of the same type to the same side of the equation. For example, x square plus 14x is equals to x plus 5. Here, 14 and 5 are of same unit. So, we will subtract 5 from both sides. So, it will be reduced to x square plus 9 is equal to x. Now we will talk about the development in the field of cubic equations. Omar Khayyam wrote the treatise on demonstration of problems of algebra containing the systematic solution of cubic or third order equations going beyond the algebra of Al-Khwarizmi. Khayyam obtained the solution of these equations by finding the intersection of two conic sections, like you can see in the figure. The next slide is of induction. The first explicit formulation of the principle of induction was given by the Pascal in his treatise Du Triangle Arithmetique. Implicit proof by induction for arithmetic sequences was introduced by Al-Karaji and continued by L. Samuel, who used it for special cases of the binomial theorem and the properties of Pascal's triangle. Abu Kamil illustrated the rules of science for expanding the multiplication. El-Karaji wrote in his book Al-Fakiri that negative quantities must be counted as terms, as it is shown in the figure, and as we already knew that positive into positive is positive, positive into negative is negative, negative into positive is negative, and negative into negative is positive. These were given by these mathematicians, and that's how the negative numbers were originated. Now, after completing the Arabic mathematical history, we have arrived on the Indian mathematical history. It includes origin of Indian mathematics, Hindu-Arabic numerals, evolution of Hindu-Arabic numerals, Sulba Sutra, origin of zero, and Indian trigonometry. In the classical period of Indian mathematics, important contributions were made by the scholars like Aryabhatta, Brahmagupta, Bhaskara II, and Varaha Mihira. The decimal number system in use today was first recorded in Indian mathematics. Indian mathematics made early contributions to the study of concept of zero as a number, negative numbers, arithmetic, and algebra. These mathematical concepts were transmitted to the Middle East, China, and Europe and led to further developments that now form the foundation of many areas of mathematics. Hindu Arabic numerals are decimal number system, that is, they are of base 10, like the today's standard number system. In today's world too, they are widely used in many regions. Here's a picture of showing Hindu Arabic numerals with the respective numerals of today's standard number system. Now we will talk about how the Hindu Arabic numerals have evolved. Hindu Arabic numerals have come a long way to be in the form they are now, and standard number system is developed from the ancient Indian numerals, that is Brahmi. As you can see in the figure, Brahmi was the first decimal number system to be developed, and then after it got converted and that spreaded around the world, and finally we got the Hindu Arabic numerals in the form they are now, and the standard number system was developed. Now moving on to the next slide, we have Sulba Sutra. As early as 8th century BC, long before Pythagoras, a text known as Sulba Sutra listed several simple Pythagorean triplets as well as a statement of the simplified Pythagorean theorem for the sides of a square and for a rectangle. Indeed, it seems like quietly that Pythagoras learned his basic geometry from the Sulba Sutra. The sutras also contain geometric solutions of linear and quadratic equations in a single unknown and give a remarkably accurate figure for the square root of 2 obtained by 1 plus 1 by 3 plus 1 by 12 minus 1 into 3 into 4 into 34 and so on, which yields a value of 1.414216, correct to 5 decimal places. Now we are on to the slide of origin of 0. The first recorded 0 appeared in Mesopotamia around 3 BC, and the Mayans invented it independently around 4 AD. It was later devised in India in the mid 5th century, spread to Cambodia near the end of 7th century, and into China and Islamic countries at the end of 8th century. The digit of 0 was given by mathematician Aryabhatta, but the operations were devised by the mathematician Brahmagupta around a century later. Aryabhatta had a significant amount of contribution in trigonometry. It includes introduction to the trigonometric function, defined the sine jaya as the modern relationship between half an angle and half a chord, defined cosine kojaya, defined versine utkrama jaya, which is 1 minus cosine, defined inverse sine utkram jaya. He gave methods of calculating their approximate numerical values. It contains the earliest tablets of sine, cosine, and versine values in 3.75 degrees interval from 0 to 90 degree to 4 decimal places of accuracy. It also contains the trigonometric formula sine of n plus 1x minus sine x is equals to sine nx minus sine n minus 1x minus 1 by 2 to 5 sine nx. That's it for the video. Thank you for watching my PPT on the topic ancient mathematics.